Burcu Ozsoy. She is a polar scientist and her research specializes in sea ice. She also led the Turkish Antarctic expedition, which I was fortunate enough to take part of back in 2018. I would do it all again, except crossing the Drake Passage, which was possibly the most uncomfortable journey of my life. Burcu, good to see you here on the NewsHour. Now, even though this is this particular calving, which we saw, is huge. I mean, I've read that it's actually the size of London. It's not really directly correlated to climate change, but global warming still does play an important role with the melting of the ice, doesn't it, and rising sea levels.
That's true. I would like to first start defining ice shelf. Simply, an ice shelf is a thick chunk of ice attached to a coastline, extending out over the ocean. Ice shelves range in thickness from about 50 to 600 meters, and some shelves persist for thousands of years. The Emery Ice Shelf is the third largest in Antarctica, with estimated floating ice area of 60,000 square kilometers, and water penetrates over 550 kilometers underneath. The iceberg, officially named D28, separated from the Emery Ice Shelf in East Antarctica last week on 26th of September. The iceberg, like you mentioned, is about 1,600 square kilometers in size and contains approximately 300 billion tons of ice, so that's huge volume. So it's the first major calving event on the Emery Ice Shelf since 1963-64. Scientists have been monitoring the site for almost 20 years and detected the calving through satellite imagery. There is currently instruments on the ice that are measuring the impact of ocean melt and ice flow. Actually, calving is the part of the ice shelf's normal cycle, where we see major calving events every 60 to 70 years. So it's been expected to break off between 2010 and 2015, and now it happened finally in 2019. So it was going to happen eventually. However, it's not exactly happened where it was expected to be.
Okay.
It's also important to mention that D28 is small relative to some of the largest icebergs in history. And I would like to mention that disintegrating ice shelves do not raise ocean level, because the ice shelves is already floating just like an ice cube in a glass of water.
Ah, that's a great example. Okay, I remember when you and I were on the Antarctic Warrior. Just to remind our viewers, that was the vessel that we spent many days on the seventh continent. You were showing me a list of all the different types, the many dozens of different types of sea ice. Explain to our viewers why sea ice is so important for our planet's climate.
Well, sea ice is simply frozen ocean water. So the definition is quite simple, but it forms, grows, and melts in the ocean. In contrast, icebergs, glaciers, and ice shelves float in the ocean but originate on the land. For the most of the year, sea ice is typically covered with snow. So sea ice keeps the polar regions cool and helps to moderate global climate. Sea ice has a bright surface. 80% of the sunlight that strikes is reflected back into the space. As sea ice melts in the summer, it exposes the dark ocean surface. So this time, instead of reflecting the sunlight, the ocean absorbs 90% of the sunlight. So a small temperature increase at the poles leads to greater warming over time, making the poles the most sensitive regions to the climate change on Earth. According to the scientific measurements, both the thickness and the extent of summer sea ice, in the Arctic region especially, have shown a dramatic decline over the past 30 years, detected by the satellite images. So this is consistent with observations of a global, of a warming Arctic.
Okay.
So the loss of sea ice has the potential to accelerate global warming trends and to change climate patterns.
So vital for our Earth's climate. All right, Burcu Ozsoy, thank you for joining us here on the NewsHour. It's good to see you again. The Turkish polar scientists, they've done and are doing some great work out there, so do follow them. Thank you very much.